Yes, I hope everybody understands me. Good afternoon. Thank you, EPIC, for the invitation. Thank you all for joining this wonderful format of online meetings. I quite remember very well the pandemic times when all that started, and EPIC was the one who keeps us all together with weekly meetings on all possible technology areas. Yes, today we talk about welding, still a very interesting topic because welding is always, let's say, project related. So you have to always discuss with the end user, with the customer, on how to really be able to solve his problem and to match his needs. So for those who don't know Precitec, maybe there are some in the audience. We are a company which is not an SME anymore. We slightly grew over the years. I'm with Precitec since 28 years right now. So we are about 750, a little bit more, all over the world. You see that we are widespread and we are active in those areas of the globe, which we see is important and where the photonics industry can play a major role, which is the US, which is Europe, and which is definitely China. So we have just released Precitec India, which maybe is also of interest for some of you. India may catch up in the near future and will play a much more important role than it was in the past. And so we are quite happy to now have founded Precitec India. So as I said, we are a small and medium enterprise. We are family owned and we reinvest a lot of money into R&D. We are quite happy to have a lot of patents, which is protecting our work, hopefully. And this work is in the key areas of laser technology and 3D metrology and sensors. This is what will be the content, more or less, of my presentation. You see some numbers here in the upper left, lower left. They always change, but luckily they change in the positive region. So we are growing and our revenue is also growing. So I will talk about ScanMaster today. Why I talk about ScanMaster? This is the solution which we provide these days for most of the e-mobility applications. And this is also one of the systems which was more or less born during the pandemic. And as you already see on that picture here, it comprises more or less all of the technologies which is Precitec is famous for. It's components for cutting components from the sensor part, which is Precitec Optronic. We have the famous laser welding monitor, LWM, here inside. And we also have camera technology. Precitec has also a subsidiary in Switzerland. For those who have the globe still in mind, there is a quite important part of Precitec R&D happening in Switzerland. This is called Precitec Vision, and all the camera activities of Precitec are going on there. So this, what we call one-stop solution, is an all-in-one 2.5D scanner. You will see later on why it's called 2.5D. And it comprises all Precitec sensor technology for pre, in, and post-processing. We try to compress all the user interfaces in one graphical surface. And so from that GUI, you can control the camera, you can control the OCT part, you can control the LWM part, and you can also control the post-processing part. So why we call that one-stop solution, or why does it comprise a lot of Precitec knowledge? So we are using an industrial scanner, which is not a Precitec scanner. We are not famous for scanners. That's why we are using one of the most robust scanner technologies on the market. But we are famous for laser cutting. And so one part of the Scan Master is the upper part of the Precitec Pro Cutter, which is the motorized collimator. So this is the 0.5, so the half D, which we can put on top on the 2D scanner. So that's why it's 2.5D. So we are able to move the collimation lens, and that's why we are able to correct the focus spot position in Z. A lot of knowledge of the Weld Master is in the Scan Master, which is mostly also the knowledge on coating. So as you may know, all the sensor technologies need a special window, a spectral window, to perform best. And this is a question of coating, and that's why we also have good contacts to famous coating companies all over Europe, which can supply us the best windows and the best beam splitters in order to have the best performance on all the sensors. This is true for the LWM as well as it's true for the camera part. And so this is what we call Scan Master. So I said already, all important areas in laser welding are covered by the Scan Master, which is the pre-process area where we do part detection based on vision, based on OCT, when we can correct all important modules in order to, when we switch on the laser, have the best beam material interaction. In the in-process, we have the monitoring part, which is the laser welding monitor, LWM, based on photodiodes, and the laser power monitor, which is what we see the best position where we can at least get an specific information on the laser power, which is going through the optics onto the workpiece. And in post-process, for sure, we can do some more monitoring, more measurements on the seam geometry, which is photodiode based, which can be camera based, whatever you see. So this is what are the technical specifications of the Scan Master, and this will be mostly the idea of how the Scan Master will look next year. So it's not only the visible components, it will be much more nicer. But we see that most of the applications will happen in the infrared area. That's why in the first run, we will apply that, or we provide the Scan Master for 1 micrometer lasers up to 8 kilowatts of continuous power. Different focusing, different collimation lens, different theta lenses, whatever will be important for the process. The set stroke here is the one which we can guarantee with the motorized collimator. You see the dimensions and the weights, and for sure there will be applications where these numbers will not fit, and we will have different configurations on a request. But what is of main importance these days is that we are also able to apply beam shaping. And that's why we are partnering with K-Labs. You may have seen that on the Photonics West and on LinkedIn, parallel to Photonics West. So K-Labs is providing with the K-Nunda high power system a very high quality beam shaping solution, 99% system transmission, because it's based on reflective optics. We benefit on the really less focus shift, on the high quality of the focus of the beam shape. That's why in all the work we have done in the past, in the last 2 years on industrial level, and before that on R&D level in a European projects. We have seen that it's a fully industrial solution going up to 16 kilowatts, which is important for us when it comes to extreme high power applications. And one of the best things of that solution is the excellent depth of field, which we haven't seen with other solutions these days. So let's go to one of the applications where we apply the Scan Master, which is a cell contacting application, one of the famous applications in e-mobility. There are some limitations in that process which we have to cover, and we can apply all the sensor parts. So in green, you see the vision, which is the pre-process, which is the camera technology. We can easily find the positions of all the important parts in the contacting application. Based on that information, we can directly set the regions where the weld needs to happen. We can apply the weld. We can measure with the autofocus, with the OCT, the set position, can apply the right focus point and then perform the weld. So this is all based, an excellent weld based on all the sensor technology, which is important. Just for your information, for example, the vision system to see the positions of all the cover part and the weld part is based on a texture-based analysis. So typically the parts are made of different material, or the material is differently structured, and this is what we see with our camera, and that's why we can very accurately see and distinguish different materials. For sure there are some let's say gray zones. Typically it's not always 100% aligned, the cover part with respect to the in that case cylindrical cell. So if it's completely out of range, we can easily stop the process or do not perform the weld, and just bring that information out to the customer that there is something wrong with the clamping or with the position of the contact, and that can be corrected afterwards. So let's talk about the set position. Even though the Canunda system is providing excellent Z-focus constants over plus or minus 3 millimeters. Sometimes maybe there is still the need to apply the autofocus, and so if you see something like that here with a poor Rayleigh length, for sure in these two situations you will not perform an excellent weld, and that weld will not really match the customer specifications. That's why we do need to do some measurements, and we do need to apply that autofocus. And this is quite easy with the OCT in the Scan Master. You see that, for example, for the mechanical strength and the electrical conductivity, the usable focus range is different than for the weld depth and the intermetallics. So if we combine those two regions, the residual usable focal range is shrinking dramatically. So we only have plus minus 1 millimeter of residual focus length. And this is what you also see here in the cross sections. So if you exceed these limits plus minus 0.3, you see that we directly run out of the limits, and the weld performance is not good. I have to admit these cross sections and these welds haven't been performed already with the Canunda. K-Labs. We will do that, and we will provide a new slide in the near future on that specific applications with the new beam shaping solution. This here is just a video on, I hope that video will start on the typical application which I was talking about. So this is what we do in our lab with just a very, very basic clamping tool. I will turn down the music a little bit. So you see, we actually have worked with beam shaping before with the NFX laser from Enlight, but now we have seen that is with the Canunda, it's definitely a better solution. So you see here in the pre-process, we do the measurement of the positions. Then we apply the welds. We have seen the positions. We have seen the set position. We can correct with the autofocus the set position. We have the process monitoring in process, the LWM, where we do process slide temperature and back reflection and the laser power. And in the post-process, then actually we can see that again. So that was more or less my contribution to the EPIC meeting today. So one additional remark, we also work on AI applications. The time was not enough today to talk about that topic. We are quite strong in AI applications based on the photodiode measurements, and we can now provide information on the mechanical strengths as well as on the conductivity, all based on the photodiode measurements. And this is hopefully what you take home. So we see a high diversity of laser concepts, and we see also a lot of challenges in industry, which makes us being able to provide flexible and application-specific solutions. I just used again that picture, which I have generated in 2016 or 2018, I don't know anymore, where I also said was of the opinion that application-specific intensity distribution is crucial for processes. And now we are able to provide that in combination with the K-Labs Canunda solution. So we can say the photons, we can tell the photons at what position they have to interact with the material to provide the best quality, to provide the best laser weld in the end. And we also apply fully implemented sensor technology to be able to control the quality and to make the customer aware that if we apply Precitec technology, he will in the end have the best solution. So again, the question afterwards to you and to the audience, so what can we do for you and what can you do for us? And before I thank you for your attention, we are hiring. So if you scan that QR code, you can directly see open job positions at Precitec, and we would highly welcome you for those who are interested to work for us in our team. Thank you very much, and I'm open to questions.